All right, so we're back for practice problem 5B from the midterm. What is the output y of n when the input is x of n equals a to the n u of n when a is between 0 and 1? All right, so we know we figured out earlier that this is our h of n, right? And then our output is, of course, going to be the convolution of x of n with h of n. And that's equal to the sum over all k of x of k times h of n minus k. Yeah, so rather than go through all this convolution, and really we can make life easier by applying some sifting properties here. So if I copy this, Control C, put that there. Let's change out h of n, how we have it defined, which is x of n involved with delta n plus 1 plus 2 delta of n plus delta of n, yeah, minus 1. And nothing changed here. Convolution is still, from the last video, distributive. So this x of n will go here, it'll go here, and it'll go here. And now this 2 is just a coefficient, so we can pull that up front. So we're going to have x of n involved with delta of n plus 1 plus 2x of n delta of n. Oh, got the convolution there. Delta of n plus x of n convolved with delta n minus 1. And now we have this, and we can apply these sifting properties up here. So we're just going to take whatever's in here, and we're going to replace it. We're going to take what's in here, and we're going to put it in here. So we get y of n is equal to x of n plus 1 plus 2 x of n plus x and minus 1. Now, recall that x of n is equal to a to the n u of n with, let's just say a is an r, 0 less than a less than 1. And now we can change out these x of n. So we're going to take what's in here, and we're going to put it here, and we're going to put it here. So we get y of n is equal to a to the n plus 1 u, you're going to step that plus 1 plus 2 a to the n u of n plus a to the n minus 1 u of n minus 1. And that is one way to write the solution. Now, I'm pretty sure Dr. Wang had it written differently in her PDF. So let's take a closer look at this real quick. Put it up here. Now we're in discrete time. So n is an integer. It's in the set of integers, right? That means n is going to be equal to dot 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 -2, -1, 0, 1, 2, dot dot dot. So let's say for n less than -1. Now, Yeah, so if n is less than -1, well, let's take a look at our unit steps here. Let's take a look at that one. That one's going to be u of, if it's less than -1, and it has to be an integer, it's going to be -2 minus 1, and that's going to be equal to u -3. Oh, that should be a plus sign right there, excuse me. So that would be -1, and then that's going to be 0. And this one's going to be 0, and this one's going to be 0, right? For n less than -1, well, that means that y is going to equal 0. Now, for n greater than or equal to -1 and n less than 0, well, if it's an integer, it can only be -1, right? So if it's only -1, then what do we have? Well, right here, we're going to have u -1 plus 1 equal u of 0 equal 1. This one will be 0, and this one will be 0. And what that implies is that, well, y is going to be equal to a, and we said n can only be -1. It would be -1 plus 1, unit step, -1 plus 1, and that's going to be a to the 0, and that's going to equal 1. Now for n greater than or equal to 0 and n less than 1, n still only an integer value, so it can only be 0 as we have it defined right here. And we know that this one's going to be on. This one's going to be, we're going to have a unit step evaluated at 0, so that's going to be on. And then we'll have unit step of 0 minus 1, so this one will be off. And what we get is that y is equal to a to the 0 plus 1, 0 plus 1, plus 2, a to the 0, 0. And that can be rewritten as a plus 2. And for our last region, we have n is going to be greater than or equal to 1. Well, if n is greater than or equal to 1, all of our unit steps are on. So we're going to write it just like this. A to the n plus 1 plus 2a to the n plus a to the n minus 1. And I think that's how Dr. Wang has written her solutions. And yep, so thank you for your time.